Hello everyone, this is Mr. Martin. In this video for geometry, we are going to be talking about proving triangles similar. So there's several methods for proving triangles similar. In this video, we're just going to talk about one of those methods. So let's review a few things first. So remember that if two triangles are similar, then the corresponding angles are congruent, and the corresponding sides are proportional. Okay, and remember, when we say proportional, this means if we make fractions with the corresponding sides, the fractions will be equal. Okay, so we just say proportional because that's obviously a lot easier way than to say all of this stuff. All right, so let's take a look at two examples of similar triangles. So in the first triangle, we have two angles, one that's 79 and one that's 67. So let's go ahead and find the third angle there. So we know that if I do 180 and I subtract those other two angles, so I'm going to add up those two angles and subtract from 180. So 180, and then I have 79, and then I have 67. I know that that last angle there is going to be 34 degrees. So that's going to be 34 degrees. All right, and now in my other triangle, I already have a 34 and I have a 67. So here's a 34, here's a 67. So we can calculate it, but we know this one's going to have to be 79 degrees because since they all added up to 180 in the other one, they're also going to add up to 180 over here. Okay, so we have this angle is congruent to this angle. We have this angle congruent to this angle. And we have this angle congruent to this angle. Okay, so all the matching angles are congruent. So let's check the sides. So let's see 30 over 34. If I reduce that, I'm going to get 15 over 17. And let's check that should be 30 over 45. I'm not sure what I did there, but we'll fix that. Okay, so 30 over 45. That's going to be 2/3. And let's check 18 over 27. That's also 2/3. And the last pair of sides, 32 over 48, is also 2/3. So we can see here that the ratio of this pair of sides 2/3, the ratio of this pair of sides 2/3, and the ratio of that other pair. So what this tells me is that all sides proportional. Okay, so we have the corresponding angles congruent, we have all the sides proportional, so that tells us yes, the triangles are similar. All corresponding angles congruent, and all corresponding sides proportional. proportional. Okay, so let's go ahead and take a look at part B. So for part B, let's do the same thing. Let's find the third angle in that first triangle. So I'm going to take 180, and then I'm going to subtract out those other two angles. So this is going to be 38 degrees. And then in my other triangle, I have 180, and I'm going to subtract out 38 and 54. So this is 88 degrees. All right, so we can see that not all the angles are congruent. Oh, we forgot to write our similarity statement and our scale factor. So let's go back here. So for this one, we're going to have our similarity statement is triangle RLG is similar to triangle N. Let's make sure we match up the correct parts. So N, C, P, and our scale factor comes from our work we did with the ratios of the sides. It's just going to be 2/3. Okay, coming back here. Now, since here we don't have the angles congruent, the corresponding angles are congruent, we really don't need to do anything else because the sides aren't going to be proportional anyway. Okay, so no, and we could just say corresponding angles not congruent. Okay, and we don't need to do these because the triangles are not similar. So again, we could go ahead and figure out the ratios of the corresponding sides, but we would see that they're not the same. All right, so I'm going to end this video here, and we will continue in the next video talking about a specific method that we can use to prove triangles similar without having to look at all three sides and all three angles every single time. So it'll make our lives a lot easier to prove triangles similar with this one particular method. All right, we'll see you in the next video.